Hi everyone, I'm Jalvis Nicasio from University of Quebec at Chicoutimi. The title of my talk is Toward Improving Architectural Diagram Consistency Using System Descriptors. Communication between practitioners is essential for the system quality. Architectural diagrams are used for communications and understanding of systems because they motivate a more active discussion among participants. However, architectural diagrams, as UML deployment diagrams, usually remain schematic and disassociate from production reality. Furthermore, architectural diagrams do not follow the evolution of the systems, and there are challenges for engineers to synchronize the diagrams with the systems in production so that they always reflect the current state of the system. We propose the use of system descriptors towards improving architectural diagrams consistency. The novelty of this research is the use of system descriptors to validate architectural diagrams consistency. We can mention Puppet, Chef, Docker Compose, and Kubernetes Pod as some of the most well-known system descriptors. Are architectural diagrams inconsistent? We informally analyze 20 architectural diagrams from technical blog posts such as Amazon, LinkedIn, Netflix, and Spotify, and for each diagram, at least one of these issues occurs. 1. They use boxes associated with different border styles, often without any subtitles or an incomplete subtitle. 2. There is a lack of consistency in the use of arrows in relation to direction, line, style, and color. We formulated the following two hypotheses. Hypothesis 1. If an architectural diagram is generated from a valid system descriptor, then the diagram is consistent. Hypothesis 2. We state that if an architectural diagram has accurate enough data to generate a system descriptor that is valid and executable, then this diagram is consistent. In our case study, we compared the diagram of a real system with a diagram generated from a system descriptor file. We developed a tool that generates architectural diagrams, named Descriptor to Architectural Diagrams, or simply DAD. DAD receives a system descriptor file as input, and it generates an architectural diagram and a diagram as code script. We compared the original architectural diagram with that generated by DAD, and we made some observations. First, we observed the generated architectural diagrams contain fewer ambiguous elements than the original diagram. Hence, the generated diagram is potentially more consistent. Then, we also note that all elements of Docker Compose have been mapped to the diagram. Finally, we saw that the position of an element in the diagram is important to understand the system. Some details of the system descriptor, such as port and password, were not mapped in the generated architectural diagram. This work presents preliminary research results, and our case study does not prove our hypothesis. However, we intend to evolve our tool to evaluate our hypothesis more deeply in a controlled experiment. Thank you very much.
All right. Hello, everyone, and welcome to the session on improving code quality. My name is Venera Ranaudova from Washington State University, and I will be chairing this session. So thank you very much, Jalvis, for the presentation. We don't have much time, so we'll jump into questions. If you have questions, please write those into the chat. Right now, I don't see questions, so I'll start with my own. So you analyzed quite a lot of architectural diagrams manually, about 20, right? Do you, from your own opinion, which one of the bad practices that you saw do you think are more dangerous in terms of, that can cause more harm?
Sorry, I cannot extend the question.
Which one do you think of the practices are really harmful? Oh, and we don't have